Welcome to the Deep Dive. Today, we're going to be exploring the world of transformer models.
Oh, cool.
Yeah, that AI that's changing like how we talk to our phones, and it's getting a lot of buzz these days.
Right. Yeah, it seems like it's everywhere.
It really is. It's kind of like the backstage pass to understanding how machines are starting to learn language almost like we do.
Yeah, and use it.
Exactly.
That's so cool.
And to break it all down, we've got an expert here with us who's going to help us really understand this. So imagine you're explaining transformer models to someone who's totally new to this. Where would you even begin?
Okay. That's a great place to start. Let's think of it like this. Imagine teaching a computer to not just read words, but to really understand them. The way that you understand the meaning of a whole sentence, not just individual words.
Right, like context.
Exactly.
Yeah.
That's what transformer models are all about. They're revolutionizing how computers grasp the nuances of human language.
Okay, so it's about context. Understanding how words relate to each other within a sentence. That already sounds way more advanced than, just spitting out words, like some of the older AI that we've seen. But how do they actually do that? What's the secret ingredient in these models?
The secret ingredient is something called self-attention. It's like giving the model laser focus. Instead of looking at words one by one, a transformer model looks at the entire sentence simultaneously. It figures out how each word connects to all the others, kind of like mapping out the relationships in a complex network.
So it's like they're seeing the whole picture, not just individual pieces. Can you give us an example of how that works in practice?
Absolutely. Think of the sentence. The cat sat on the mat, but it was too small. We instantly understand that it refers to the mat, not the cat. Transformers can do this too, because they analyze how every word relates to every other word in the sentence.
That's fascinating. It's like they're solving a mini puzzle with each sentence. So is that what sets transformers apart from those older AI models we might have heard of before?
You're exactly right. Older models were like reading a book one word at a time. Slow, and they couldn't remember what happened a few pages back. Transformers are like reading the whole book at once, making them much faster and better at understanding those connections between words that are far apart.
That's a helpful analogy. It sounds like these transformers are really shaking things up in the world of AI. But how are they being used in the real world? I've heard a lot about ChatGPT lately. Is that connected?
ChatGPT is a great example. It's powered by a transformer model. And it's showing everyone just how powerful this technology can be. You can have a conversation with it, ask it questions, even get it to write different kinds of creative content. It's pretty amazing to see it in action.
Yeah, it's definitely become a popular tool. Even I've been playing around with it.
Yeah.
But are there other applications too beyond just chatbots?
Oh, absolutely. Transformers are popping up everywhere. Think about real-time translation that's powered by transformers. They're also helping scientists understand complex data like DNA sequences, which could lead to breakthroughs in medicine. It's not just about words anymore, it's about analyzing patterns and making connections in all kinds of data.
That's incredible. So from translating languages to potentially finding cures for diseases, it seems like this technology is already having a significant impact.
And we're only at the beginning. As these models continue to evolve, the possibilities are almost limitless.
Okay, we've got a sense of what they are and what they can do. Now let's get a little bit more technical. How do these transformer models actually work under the hood? Can you give us a simplified explanation for those of us who aren't computer scientists?
Imagine it like this. First, the model takes words and converts them into numbers, like assigning each word a unique code. This lets the model understand language in a way that computers can process.
So it's like turning words into a secret code that the computer can decode.
Exactly, but then it needs to remember the order of those words. Just like the order of letters matters in a word, that's where positional encoding comes in. It's like adding a little note to each word saying, hey, I'm the third word in this sentence, remember that.
So it's not just about the words themselves, but their place in the sentence. What happens next?
This is where the self-attention magic happens. The model analyzes the relationships between all those coded words simultaneously, figuring out which words are most important to focus on and how they connect to each other. It's like the model is drawing lines between the words to map out their relationships. Yeah, it's like the model is creating a mind map where words that are closely related are linked together, and those connections help the model understand the meaning of the sentence.
So it's like piecing together a jigsaw puzzle, where each piece is a word, and the connections between them reveal the bigger picture.
That's a great analogy. And this process is repeated multiple times with each layer building on the previous one to refine the understanding. It's like the model is reading the sentence over and over, getting smarter each time.
It's like each layer adds another level of depth and nuance to the model's understanding.
Exactly. And finally, the model uses this rich understanding of the sentence to generate a response. It could translate the sentence, answer a question, or even write a poem.
So it's like the model is using all that knowledge it's gained to create something new, something meaningful based on what it's learned. That's really impressive. So we've talked about how these models work, but you mentioned earlier that transformers are much better than those older models. What are some of the advantages they bring to the table?
One of the biggest advantages is speed. Because transformers process information in parallel, they can analyze huge amounts of data much faster than older models, which processed information sequentially. It's like the difference between having a team of people working on a project simultaneously versus one person doing it all step by step.
That makes a lot of sense. So it's not just about being faster.
Yeah.
It's also about being able to handle those long-range dependencies we talked about earlier, those connections between words that are far apart in a sentence.
Exactly. Transformers are much better at understanding those long-range dependencies. This is crucial for understanding complex texts, where the meaning of a sentence might depend on something that was said paragraphs earlier. Think about a scientific paper or a legal document.
So for understanding those complex texts, transformers are really the way to go. It's fascinating to see how these models are being used in so many different fields. You mentioned earlier about their impact in medicine. Can you tell us more about that?
Absolutely. One of the most exciting areas is drug discovery. Imagine you're trying to design a new drug to target a specific protein involved in a disease. You need to understand the protein's structure and how it interacts with other molecules. This traditionally involves years of lab work and trial and error.
It's like trying to find a needle in a haystack. Incredibly time-consuming and complex.
But transformers are changing the game. They can analyze huge databases of protein structures and identify patterns that would be impossible for humans to spot. They can even predict how different molecules will interact with each other, helping scientists narrow down their search for potential drug candidates.
So they're acting like a super-powered research assistant, helping scientists to make more informed decisions and focus on the most promising avenues of research.
That's right. And because they can analyze data so quickly, they can significantly reduce the time it takes to develop new drugs, potentially bringing life-saving treatments to patients much faster.
That's truly remarkable. It sounds like transformers are revolutionizing the way we approach drug discovery. What about other areas of medicine?
They're also being used to improve disease diagnosis. Think of a model trained on thousands of medical images. It can help doctors identify subtle abnormalities that might be missed by the human eye, leading to earlier and more accurate diagnoses.
It's like having an extra pair of eyes, incredibly trained eyes, to help spot those critical details that could make all the difference in a patient's treatment.
Exactly. And they're also being explored for personalized medicine by analyzing a patient's genetic data, medical history, and lifestyle factors. Transformers could help predict their risk of developing certain diseases and recommend tailored treatment strategies.
It's almost like having a personalized health advisor that can provide insights and recommendations based on your individual circumstances.
That's a great way to put it. And beyond medicine, transformers are making waves in fields like scientific research, customer service marketing, finance, and manufacturing.
It seems like there's no limit to the potential applications of these models. It's mind-boggling. We've seen what they can do. But as these models continue to evolve, where do you see this technology going in the next 5 to 10 years? What does the future hold for transformer models?
That's a great question. We're still in the early stages of this technological revolution, but I believe we'll see transformers becoming even more powerful, versatile, and integrated into our lives. One exciting area is the development of multimodal transformers.
Multimodal, what does that mean?
It means models that can seamlessly process and understand information from multiple sources, not just text. Imagine a transformer that can analyze text, images, audio, and video all at once. It would be like having a model that can understand the world in a much more holistic way.
So it's like a model that can see, hear, read, and understand everything all at once.
Yeah.
That's a remarkable leap forward from where we are now.
Exactly. These multimodal transformers could revolutionize fields like robotics, where robots need to understand their environment and interact with it in a natural and intelligent way. Imagine a robot that can not only see and hear, but also understand what it's seeing and hearing and respond accordingly.
That opens up a whole new world of possibilities for how robots can interact with humans and their environment. What other exciting advancements are you anticipating?
I think we'll also see significant advancements in the explainability of these models.
Yeah.
Right now, these models are often seen as like black boxes. We know they work incredibly well, but we don't always understand why they make certain decisions.
So there's a bit of a mystery surrounding their decision-making processes. Why is explainability so important?
Well, especially in areas like healthcare and finance, we need to be able to trust the decisions these models are making. We need to understand the reasoning behind their conclusions, especially if those conclusions have a significant impact on our lives.
It makes sense that we'd want to peek inside that black box and see how the gears are turning.
Yeah.
So are researchers working on making these models more transparent?
Absolutely. Researchers are developing techniques to make these models more explainable so we can understand the steps they take to reach their conclusions. This is crucial for building trust and ensuring that these models are used responsibly.
That's a positive development. Are there any other advancements on the horizon that you're particularly excited about?
I think we'll also see a rise in personalized and adaptive learning experiences powered by transformers. Imagine educational platforms that can tailor the learning content and pace to each individual student's needs and learning style. It's like having a personalized tutor that can guide your learning journey and help you achieve your full potential.
That's a fantastic vision. It sounds like transformers have the potential to not only revolutionize how we learn, but also make quality education more accessible to everyone. What an incredible impact this technology could have on society.
Yeah, definitely. We've covered a lot of ground today exploring the world of transformer models, from their inner workings to their real-world applications and even a glimpse into the future. What do you say is the most important takeaway for our listeners today?
That's a great question to wrap up with. I'm curious to hear your thoughts.
Yeah.
What do you think is the most crucial thing for our listeners to understand about this transformative technology?
I think the most important takeaway is that transformer models represent a profound shift in how we interact with information technology and each other. This isn't just about faster calculations, it's about machines starting to understand the world a bit more like we do.
It's almost like we're witnessing a new era of computing, where machines can not only process data, but also extract meaning and insights from it. And as you said, we're only at the beginning of this journey.
Exactly. As these models continue to evolve, they hold the potential to reshape our world in ways we can only begin to imagine. It's an exciting time to be alive, to be witnessing this technological revolution unfold.
Well, I have to say, this deep dive into the world of transformer models has been incredibly eye-opening. From understanding how they work to seeing their impact in fields like medicine and beyond, it's clear that this technology is a game changer. But it's also a technology that comes with responsibilities.
Absolutely. As with any powerful tool, it's crucial that we use it wisely and ethically. We need to be mindful of the potential risks and ensure that these models are developed and deployed in a way that benefits society as a whole.
It's like we're at a crossroads where we have this incredible technology with the potential to solve some of the world's biggest challenges, but we also need to be careful not to create new problems in the process.
That's a great way to put it. It's a balancing act, and it's one that requires ongoing dialogue and collaboration between researchers, policymakers, and the public.
It's a reminder that technology is never neutral. It's a reflection of our values, our choices, and our aspirations. And as we continue to develop these powerful AI systems, it's crucial that we embed those values of fairness, transparency, and accountability into their very design.
Well said. It's a collective effort, and it's one that requires us to stay informed, engaged, and critical. We need to ask the tough questions, challenge assumptions, and hold each other accountable.
I think that's a powerful message to leave our listeners with. The future of transformer models, and indeed the future of AI, is not predetermined. It's a future that we are actively shaping with every decision we make, every line of code we write, every conversation we have.
And that's what makes it so exciting. It's an invitation to participate, to contribute, and to shape the future we want to see.
Well, I want to thank you for joining us on this deep dive. Your insights have been invaluable, and I know our listeners have gained a much deeper understanding of this complex and fascinating technology.
It's been a pleasure. I always enjoy opportunities to share my passion for AI and to engage in thoughtful conversations about its potential impact.
And for our listeners, we encourage you to continue exploring, learning, and questioning. The world of AI is constantly evolving, and there's always something new to discover. Thanks for joining us on the deep dive. Until next time, keep your minds open, your curiosity piqued, and your imaginations ignited.